Hey everybody, welcome to Altium Academy. I am Zach Peterson. I'm your host and your local technical consultant for Altium. And today we're actually going to look at how to add teardrops in Altium Designer. Now, there was a comment on one of our earlier videos about teardrops, and this is when we were talking about how to size pads in your vias when you're routing. Placing pads on vias is actually really important. It's not just to allow you to make an electrical connection, it's also important for reliability, and those need to be sized properly. However, there was one good comment about teardrops, and we want to look at that right now. Bob Wilson writes, I would not trust a board that doesn't have teardrops, or a designer that resists teardrops. Great video as usual. I would add, try to go as big a via and pad as possible. 10 mil drill is okay, but bigger is better. Bob, you're right, bigger is better. Bigger isn't always feasible, but you're right, bigger is better when it comes to vias and the pads that are used on them. However, in those instances where you can't fit a larger via and a larger drill into the board, simply due to the fact that you've got a high interconnect density on the board, you can actually add some level of reliability to the interconnect with teardrops. I'm going to show you how to add those. Let's go ahead and get started. I'm looking at a PCB layout that I've been playing with lately, and this is actually something that has been modified from a project that's by Mark Harris. It's actually up on the Altium blog. We'll go ahead and link to the original files. Those files can actually be downloaded from GitHub. You can take it and do whatever you want with this project. What I'm actually looking at here is on the bottom side, and the layout was re-engineered for another purpose in this, but I like it because it has the LTE transceiver in it, and it's got the GPS transceiver. So that's kind of the main stuff that I wanted out of this project. We have a product that I want to make very high reliability, and you'll notice in this entire set of routes that I'm showing on the screen, I have no teardrops. So you might be wondering, what's a quick and easy way to add teardrops to this particular design, and how big do they need to be? So there is a tool in Altium Designer that allows you to just basically go in and select teardrops, and you can just start adding teardrops to stuff. You can do it to just objects that you select. You can do it to everything. If they're already there, you can remove them. You can do a curved style or a line style. And sometimes when you go to add in a teardrop, if there's any like nearby copper pour, or maybe there's a nearby trace, sometimes what'll happen is that'll actually create a DRC violation. It might cause a short circuit. Generally, it'll just cause like a clearance error. You can actually force it to add them regardless of what's nearby, so it'll actually violate the DRCs. So because of that, if you do use this option, just make sure to use or to run a design rule check afterwards to find any clearance errors. And then you've got these different areas where you would typically find teardrops. So on high reliability products that I've built, I've never been asked to do it on a T-junction, but you can do it on a T-junction here where a trace essentially breaks off and goes two different directions. I have been asked to do it on SMD pads, on vias, and then on these areas where tracks essentially break out and go to a larger width. This is actually nice here on tracks because essentially what the teardrop is doing is it's applying a taper for you. So you don't have to like manually taper something in like with a polygon pour. I mean, you can do that if you want to, but the teardrop essentially applies that taper for you. So what we're gonna do is, let's just say we want to apply teardrops just to these four objects. I'm gonna go in here to Tools and Teardrops, and here I'll just do Selected, I'll do Force, and here, now the question we wanna look at is how big do these teardrops need to be? So just kind of as an example here, what I'm gonna do is I'm gonna make this 100%, basically 100% of this diameter, and then 100% of the diameter vertically, and if we hit OK, you can see that it automatically adds these, and looks like they came out in the curved style. We want to basically ask, is this big enough? Well, the answer to the question of whether it's large enough essentially depends on how much of an annular ring we are going to expect if this drill is off from dead center in this pad. Obviously, in the manufacturing process, it's not perfect. There's going to be some wander in this drill hit. It could hit essentially anywhere inside of this pad. And ideally, you size the pad to be large enough to accommodate any of that wander and still leave a leftover annular ring around the edge of wherever the pad is. So let's just say for a moment that the via hit or the drill hit is right here along this edge. Well, you'll notice here by setting the width wide enough, we're actually able to ensure that even if this drill hit is right here along this edge and starts to sever the trace, there's going to be enough copper all the way around that drill hit in order to ensure that there's a reliable electrical connection. Now, mechanically, maybe that connection isn't as robust as a dead center drill hit. However, there's enough copper there for a reliable electrical connection. Whereas if we essentially just had no teardrop and it hit right here, there's a chance that it could significantly cut through the pad and increase the resistance here. And it could also eventually break along this interface if there's any like high vibration or frequent thermal cycling. So those are both issues to think about in this type of situation where you need a high reliability device. What I prefer to do is set them longer and set them wider, just so that even if we do end up with something along the very edge and we need to ensure reliability, that we're always going to have just a little bit of copper here, even though there may be a very thin annular ring. So that's kind of an extreme case, but the whole point behind high reliability designs is to account for all of those extreme cases and to make sure that you're designing the board to account for those. If you're ever in here and you want to remove a teardrop, just select the regions option in the selection filter. Just click in the teardrop area. You'll see that it highlights. You can hit delete, and there you go, it's gone. Hit undo, it'll bring it back. One thing that's kind of fun is if you have a teardrop and you want to copy it, you can. Basically, I can just do this and select that pad. I can come down here to this other pad, hit paste, and then you'll notice it basically just copied it just like you would any other object. So that's kind of cool. Probably not the most efficient way to do this in this particular type of design where you've got all of these different vias everywhere, but still something you can do if you want to. The other thing I prefer to do is instead of doing this curved style, what I actually prefer is the line style. So the line style, the reason I like that is because you'll notice the curved style kind of curved in right here where my mouse is. Whereas if I do this with like the line style, I think the line style is actually a little bit better because it leaves just a little bit more copper along this portion of the trace. And so you can kind of see that here if I go back into teardrops and apply a straight line style, hit OK. And so you'll notice it leaves just a little bit more copper here. If you really want to go with high reliability, you would basically take this and really stretch it out like this, kind of like I'm doing here with the snap tool, and you see it really brings it out and goes wide. Let's say I want to get really wide with this teardrop. I'll go back into the tool, and here I can put 150%. Hit OK, and you'll notice it doesn't actually apply that big of a percentage, okay? So it's not gonna exceed a certain amount. So what you would have to do is you can actually drag this, and if you need a really highly reliable connection here across this entire via, you can stretch this out so that it comes out like this and makes contact with the pad here, kind of where it tangents, and you get a very nice wide teardrop coming into the pad. So this is one way you can do that. And then, just like I said earlier, if you want, you can grab this, can copy it over to all of these other vias. So you notice when I applied that, it comes up with a clearance constraint. And that's because if I go over here to polygons and I re-pour this, now it's cleared up. And it was just barely, like this little part of the polygon right here where my mouse is, just barely enough copper to trigger a design rule error. So that just goes to show if you're gonna start playing around with teardrops and you might create a design rule error, run a design rule check afterwards, watch for some of these teardrops because they'll actually flag a violation in the DRC. And then if you have any polygon pour on the same layer, just grab it, hit the re-pour button, and call it a day. So that's how you access the teardrop tool. That's how you use it. That's some of the stuff you can do with teardrops. And I kind of like this taper style. I use it on multiple things, whether it's just vias or routing into very fine pitch pads. It's really simple to use and really simple to access in Altium Designer. All right, everybody, so thanks for sitting through this, because I know that this has been requested in the past by some viewers. Hopefully this shows you how to access and use the Teardrops tool. Very useful and important in high reliability designs. All right, thanks everybody. And on this type of stuff, definitely don't forget to call your fabricator.